In 1964, Stephen H. Dole and Isaac Asimov got together and wrote a cute little book entitled, Planets for Man. Planets for Man. By Stephen H. Dole and Isaac Asimov. Based on the RAND Corporation research study Habitable Planets for Man by Stephen H. Dole. Preface. The aim of this book is ambitious in that it tries to suggest answers to some very basic questions about the ultimate goals of space travel. Such projections are risky considering that our knowledge of the universe is still so incomplete, but for the adventuresome of mind and imagination who will, we hope, accept it in the spirit in which it is offered, it will open glimpses of possible new horizons for future generations of human beings. Many of the subjects discussed herein are highly controversial, for there is no general agreement among scientists on numerous questions. As an example, on concepts of the formation of stars and planets, cosmogony, there are at least as many theories as there are writers on the subject. No two of these theories agree in all their basic details, and even where there is some agreement now, it is possible that drastic revisions will have to be made in the future as more evidence is accumulated that requires the abandonment of some ideas and the introduction of new ones. This has happened many times in the past and undoubtedly will continue to occur until all the pertinent facts have been gathered and all the pieces fall together in a coherent and entirely convincing manner. No attempt has been made to present all points of view on controversial questions or all the current theories that differ from those advanced here. To have made the attempt would have resulted in a hopelessly long and complicated book. Those desiring to see more detailed technical substantiation of the ideas presented might wish to consult the book by one of the authors. Habitable Planets for Man, on which the present one is based. The numerous graphs, tables and specific references to published papers and other bibliographic material contained in Habitable Planets for Man have been omitted from the present book, which is meant for the general reader. For those who wish further information, a list of related reading material containing some of the more general works consulted has been included at the end of the book. Chapter 1. The Coming Surge. The star Alpha Centauri is our nearest neighbor in space beyond the solar system. By earthly standards, nearest neighbor is not very close at all, for Alpha Centauri is 25 trillion miles away. Light, which travels 186,000 miles per second, takes 4.3 years to travel from Alpha Centauri to ourselves. We can therefore say that Alpha Centauri is 4.3 light-years away. Yet such is the vastness of the universe that no star is closer than Alpha Centauri, while billions of stars are much more distant. Let us look then more closely at this far distant nearest neighbor of ours. Because of its nearness, Alpha Centauri, though not one of the very luminous stars, is the third brightest star in the sky. It is not visible, however, from most of the north temperate zone, so Americans and Europeans do not ordinarily see it. Alpha Centauri is actually a triple star system. The two larger components of the system, Alpha Centauri A and Alpha Centauri B, revolve around each other in a period of 80 years at a mean separation of about 23 astronomical units. An astronomical unit, or AU, is the average distance from the Earth to the Sun, about 93 million miles, so that 23 AU represent about 2.1 billion miles. The third member, Alpha Centauri C, some 10,000 AU, about 1 trillion miles, removed, revolves around the pair A and B in a period of the order of a million years. The two stars Alpha Centauri A and Alpha Centauri B are each very much like our own Sun, and either or both might conceivably possess a habitable planet like our Earth. As of now, we have no way of actually telling whether such a habitable planet circles Alpha Centauri A or Alpha Centauri B, but suppose one does. We might then visualize an intelligent creature on such a planet surveying his night sky as we survey ours. The intelligent Centaurian studying the stars would see almost unchanged the familiar constellations we see from the Earth. His star, you see, is so close to ours as compared with the vast scale of the universe that the general view of the night sky is just about the same there as it is here. He would see the Big Dipper, Orion, and the constellations of the zodiac. But there would be one outstanding addition. Instead of the 5 bright stars making up the familiar zigzag of the constellation Cassiopeia as we see it, our Centaurian would see 6. The 6th star would extend the zigzag pattern one more step, and it would be 6 times brighter than any of the other 5. That 6th star would be our Sun. As far as our Centaurian would be able to see, there would be nothing particularly remarkable about this star except that it would be brighter than most. Barring that, it would look very much the same as many others within his view. If his science were no more advanced than ours, he would have no way of detecting the fact that what was to him the brightest star in Cassiopeia possessed a life-bearing planet in orbit around it. He could only speculate and wonder as we speculate and wonder about Alpha Centauri and about other stars. The promise of space. And why bother with all this speculation and wonder? Until very recent years, the only excuse that could possibly have been offered was that men were irremediably curious and had to wonder for the sake of wonder itself. But now we have a more practical reason to offer, for mankind stands at the threshold of space flight. To be sure, the plans now being made for the manned exploration of the space near the Earth may be likened to the first efforts of a baby who has not yet learned to creep. It is a learning process with only short-term goals as yet. Our first faltering steps will take us to the Moon. More confident steps will lead us on to explore the surface of Mars and the cloud cover of Venus. Later on we will reach the other planets of the solar system. None of these worlds would be comfortable for us, but we need not be too distressed over this fact, for our exploration of our sister planets will represent but the barest beginning. Consider where the process will lead us when we have really learned how to traverse space with assurance and ease. This book takes the long-term viewpoint. It looks forward to a time when man will be able to seek and find habitable planets beyond the solar system. To be sure, we cannot do this now, and we cannot even see how the vast spaces between the stars can be bridged at all within the scope of our present limited knowledge. However, we are barely started on our upward climb as self-aware and knowledge-seeking creatures. There is much more to learn than has already been learned, and in view of the rapid and accelerating strides of science and technology over the past 50 or 60 years, it does not seem outlandishly optimistic to suppose that practical methods for leaping the interstellar gulfs will be developed in the not-too-distant future. Therefore, let us assume that this is so, and consider not the means of reaching the stars but our destinations. Once we set out on our journey to the stars, by whatever means, let us ask the question, toward which stars ought we to travel? Does it make a difference? Certainly it does, if we but consider what the goals of man's space flight might be. One goal most certainly would be to increase our knowledge and understanding of the universe, to attempt to learn about the origin of matter, of galaxies, even of life. A second might be to find new sources of energy and raw materials. But surely there is a third purpose that ought to prove the most attractive goal of all, that of finding new habitable planets. As it is now, one planet, the Earth, supports the entire human race. One planetary catastrophe could completely destroy us. But if the human race were living on a number of planets scattered around the galaxy, its immortality would be assured. What's more, the opportunities for variations in culture and in outlooks would be vastly multiplied, and the interactions among the multitude of human subgroupings might vastly accelerate the overall progress of mankind toward ultimate mastery of the physical universe. But even if the possibility of interstellar flight is assured, it will remain an expensive and difficult proposition for a long time. We will not be able to afford to wander through interstellar space at random. We would have to guide our ships with care and thought in this great search that is to come. It is not too soon even now to begin to ask ourselves, where ought we to begin in the coming search for habitable planets? And what is the probability of finding them among the nearby stars? This book tries to give some reasonable answers to these questions. Approach to the problem. The search for other habitable planets cannot be direct. Objects of planetary size at the distances of even the very closest stars cannot be detected optically under even the most favorable conditions. The use of the Palomar Mountain 200-inch telescope, the world's largest, could not help us. Lacking direct evidence, then we will have to use indirect reasoning. The task will be all the harder since we will set unusually stringent conditions. Many astronomers have speculated before now on the subject of life on other planets, but only in a relatively vague and qualitative manner. We, however, will aim at obtaining as exact a set of criteria for habitability as is possible. We will try to establish reasonable quantitative limits for environments favorable to man, and then calculate the prevalence of habitable planets that meet those limits. To do this we will have to have a starting point, and ours will be the assumption that our solar system is not an extraordinarily rare assemblage of bodies but that it is rather a typical planetary system, and that its members can be treated as a good although not numerically large sample of the sorts of bodies that exist in the proximity of other stars. It is only fair then to begin by asking if a habitable planet other than the Earth itself exists in the solar system. To that the answer must be no. The reasons for this negative answer will be considered later in detail, but here are the conclusions in brief. Mercury is too small to retain a breathable atmosphere. It is so close to the Sun that the Sun has apparently stopped its rotation. Its surface no longer has an alternation of day and night, its sunlit side is therefore too hot and its dark side too cold. Venus, although of the right size, is close enough to the Sun so that its rotation too has apparently been slowed drastically. Its atmosphere probably contains too much carbon dioxide to be compatible with human life, and its surface temperatures are almost certainly too high. The Moon, our satellite, is at the same distance from the Sun that the Earth is. It is therefore at the correct distance from the Sun for habitability, since the Earth itself quite obviously is. Nevertheless, the Moon is too small to retain an atmosphere or even to produce one suitable for man. Because its rotation with respect to the Sun is slow, its days are too hot and its nights are too cold. Mars is also too small to produce or retain an atmosphere suitable for human beings. It is far enough from the Sun so that even if it were massive enough, its average surface temperatures would probably still be too low for it to be considered habitable. Jupiter, Saturn, Uranus and Neptune are so massive that they have retained enormously thick atmospheres consisting mainly of hydrogen and helium, which are unbreathable by man. The satellites of the major planets are too small and too cold, so are the asteroids. Pluto is also too cold. Perhaps it may seem to you that we are too cavalier in this rapid dismissal of the bodies of the solar system as non-habitable. Surely Mars at least is often spoken of as a possible abode of life, and men do plan to establish colonies on the Moon. Let us then explain precisely what we will mean by the word habitable when used in this book, and point out in particular that as used here it is not synonymous with life-bearing. Planets might be habitable in a variety of different senses. Planets could, for instance, support some unknown form of life with a chemistry basically different from that of life on Earth. We might, for example, speculate about organisms living in seas of liquid ammonia on Jupiter or breathing gaseous sulfur on Mercury. Again, planets might be inhabited by carbon-based life as we know it, but under conditions that could support only microscopic forms of such life or only specialized forms specifically adapted to extreme environments. Mars might belong to this group of planets. There is indeed the possibility that a form of plant life exists on the planet, but if so, it must to all appearances consist only of very small or even microscopic organisms because of the extreme scarcity of water on the Martian surface. Then too, planets might be made habitable for man himself at the price of extensive feats of engineering. The atmosphere or surface of a planet might be remodeled so that people could live there in large numbers. On Mars or even on the Moon, water might be obtained from surface rocks, food might be grown under glass, and people could live in hermetically sealed hothouses containing breathable atmospheres. Such highly artificial conditions involving underground cities or domed cities on the surface would probably never be entirely independent of supplies from Earth, and would be vulnerable to even temporary breakdowns in the complex technology serving to support the system. No planets of any of these types are to be considered habitable for purposes of this book. We will define a habitable planet as one on which large numbers of people can live comfortably and enjoyably without needing unreasonable protection from the natural environment and without dependence on materials brought in from other planets. In short, the vast majority of habitable planets by our view will turn out to be worlds very much like the Earth. It is in this sense that none of the bodies of the solar system other than the Earth itself is habitable. If other habitable planets exist, they can be found only in the neighborhood of stars other than our Sun. Our plan of attack on the problem we have set ourselves then falls into three parts. 1. We will first describe the environmental conditions required to make a planet habitable. 2. We will then work out the combination of astronomical circumstances that will produce these conditions. 3. We will finally estimate the probabilities that the necessary combination of astronomical circumstances will be found elsewhere in the galaxy, and in particular where they might be found among those stars relatively close to the Sun. Let's begin then with the first part.